Okay, walk us. Today we're in journal page 64, defining and evaluating a logarithmic function. Okay, example 1. Complete the input-output for f of x equals log base 2 of x, and then graph f of x equals log base 2 of x. Okay, step 1. Complete the input-output for f of x equals log base 2 of x. Okay, so what we're going to do is going to go to Google. We're going to type in Desmos graph and table. All right, click here. And we need to delete these values and this equation. We're going to go, and I don't know what that is. Let's get that out of the way. We're going to go to function, miscellaneous, and then we want log. Make sure you pick the one that has the base at a. So now that's log base 2 of x. Okay, now we're going to come over here and complete the table. So 0.25, 0.50, 1, 2, 4, 8. Okay, so that's -2, -1, 0, 1, 2, 3. All right, so there's our table completed. All right, now let's graph f of x equals log base 2 of x. Okay, well, first off, we see that we have a vertical asymptote at x equals 0. Okay, so let's graph that. All right, now let's graph our points. So -0.25, -2, which is here, -0.5, oh, I'm sorry, 0.5, -1 is here. Okay, and then 1, 0 is here. 2, 1, 4, 2, and 8, 3. All right. All right, I think I made a mistake on this point. Let me double check. So negative, or 0.25, -2, 0.5, -1. So if you ever make a mistake on a point, you can either put an X over it, or you can use whiteout and white out that point. Okay. I did the X, and now I'm gonna white out the point as well. Okay. All right. Go ahead and finish up the graph. All right, now let's take a look at step 3. Okay. Step 3, the domain of f of x is x such that x is greater than 0. Step 4, the range of f of x is y such that negative infinity is less than y, less than infinity. Step 5, the end behavior of f of x is as x approaches infinity, f of x approaches infinity. As x approaches 0, f of x approaches negative infinity. Okay, so step 6, the graph only x-intercept is at x equals 1. Okay. And let me fix these steps using good old whiteout. Okay, so step 7, the graph has no y-intercept. Step 8, the graph has the y-axis as an asymptote. Step 9, the function has a negative values on the interval 0, 1, and the function has positive values on the interval 1 to infinity. And then step 10, the function is increasing throughout its domain, the function never decreases. All right. All right. Example 2. Complete the input-output for f of x equals 2 to the x, and then graph f of x equals 2 to the x. Step 1. Complete the input-output for f of x equals 2 to the x. Okay, so again, we're going to go back to Desmos. I'm going to clear out these values. I clear this out. I'm going to do 2 upkey x, and then we're going to plug in the value. So negative 2, negative 1, 0, 1, 2, 3. Okay, so our values are 0.25, 0.50, 1, 2, 4, 8. Okay. All right, so there's the table. All right, so graph. First off, we see that we have a horizontal asymptote at y equals 0. So let's go ahead and graph that. All right, now let's graph the points. So the first point is negative 2.25, negative 1.5, and again, those kind of points you just approximate. 0, 1, 1, 2, 2, 4, 3, 8. All right, there's your graph. All right, go ahead and finish up the graph. All right, let's take a look at step 3. Okay. The domain of f of x is x such that negative infinity is less than x less than infinity. Step 4, the range of f of x is y such that y is greater than 0. Step 5, the exponential function is 1 to 1, so no restrictions on its domain are needed in order for its inverse to be a function. Step 6, find the inverse of f of x equals 2 to the x. Okay, so first off, we have f of x equals 2 to the x. Your first step is you change f of x to y, so you have y equals 2 to the x. Then you switch x and y, so x equals 2 to the y. Now, we need to take log base 2 of both sides. So log base 2 of x and log base 2 of 2 to the y. Okay? Now, log base 2 of 2 cancels and you're left with y. So, log base 2 of x equals y is your inverse. Okay? And then step 7, the domain of f inverse. And when I say f inverse, when we say inverse, we're saying that in this case, y is the inverse, so f inverse equals that. Okay? So the domain of f inverse is x such that x is greater than 0. And step 8, the range of f inverse of x is y such that negative infinity is less than x less than infinity. All right, go ahead and finish up example 2. All right. Example 3. Enter the exponential equation b to the x equals y in logarithmic form. The logarithmic form of b to the x equals y is log base b of y equals x. All right, go and finish up example 3. Example 4. Enter the logarithmic equation log base b of y equals x in exponential form. The exponential form of log base b of y equals x is b to the x equals y. All right, go and finish up example 4. All right. Go and finish up your notes and examples and have a wonderful Wildcat day.